Hi everyone, my name is Everett Toews. I'm a developer advocate at Rackspace. I'm going to try to get you a little more effective with Docker Swarm today. Oh, shoot. That pretty accurately sums up what I do. I jump off things and put myself in harm's way to amuse my children. Okay, so just to give you an idea of what we're talking about today, we're going to introduce you to Karina, Containers as a Service product from Rackspace. We're going to immediately jump into getting started with Swarm, and then we're going to take you a little bit deeper and get you effective with Docker Swarm. All of this is online. This presentation is online right now. You don't have to take pictures. You can just kind of focus on the presentation, and you can visit this at your leisure. All of these are links that'll jump you into specific places into the presentation. If you have to leave, no problem. The only thing you need to remember is rack.to/swarm will take you to this presentation right now. Okay, so let's get swarming. Let's talk Docker Swarm. Swarm is effectively Docker's answer to clustering. So there's a lot of these container orchestration tools out there now, and Docker is, or I should say Swarm is Docker's entry into this field. It's a clustering solution that allows you to schedule your containers across a group of nodes. So let's talk a bit about how that works. If you've worked with Docker up to this point, it's very likely that you've been in this situation on the left. I know certainly we have at Rackspace on my team. We're managing individual Docker nodes out in the cloud, or maybe you're managing them, in your data center on bare metal or where have you, or in virtual machines on your VMware instances. Could be anywhere, right? But the point is that you've got these individual Docker nodes, and there's a Docker engine on each one of them, or Docker daemon. I'll use the two interchangeably. And you're talking to each one of those nodes individually, and you care very deeply about what containers go onto what nodes. It's like you're placing pets out into kennels and letting them roam around for a little bit. So you're working with each of those individually via I have CLI written out here, but that could very well be some SDK or something like Ansible that can also coordinate containers. It's all via the Docker API. But now in this new Swarm world with clustering capabilities, we'll use the Swarm software to actually join these nodes together so we can treat them as a coherent whole. Now you only have one endpoint to talk to, and it's actually Swarm itself that worries about where it schedules your container across the nodes. Come right on in. Come right on in. There's lots of spaces over here on the right from your perspective. Yep. So that kind of sums up Swarm in a sense at a high conceptual level. What are some of the benefits of actually utilizing Swarm over just these individual nodes? Kind of, in one sense, you can consider it that the difference is there is no difference. Swarm has the same API as the Docker engine. So if you've been working with Docker to date, you can take all of your learning, experience, skills, knowledge, and apply that almost immediately to Docker Swarm. Because they have the same API, you're running the same commands. So you can apply what you've learned, as I said. So that also means you can take all the tooling that you've built up around Docker and apply it to Swarm immediately. And the entire ecosystem of tooling that's been built up around Docker and apply it to Swarm immediately. There are some caveats there, and we'll get into that in the second part of the presentation. Now, of course, because it's a cluster, one of the primary things it does for you is schedule your containers across those nodes. Like I said, you're no longer talking to individual nodes. You're talking to one endpoint, and you're treating that cluster, you can think of it as a single Docker node. There are several strategies that Swarm ships with by default that you can choose on how you want to schedule your containers. There's the spread strategy that basically does round-robin distribution of your containers. There's bin pack that packs each node with as many containers as it can before moving to the next node and packing it with as many containers as it can. And then there's random, which is just random, of course, right? Now, it's actually not always the case that you necessarily totally don't care where your containers are going to be scheduled. It could be that you need, like, the applications within your containers have some performance requirements from the actual physical hardware that they're running on. For instance, if you've got an I/O intensive application, maybe a database or what have you, and it absolutely requires to be on a node with SSDs, when you create that node, you label it with an SSD, with the label SSD, literally the 3 characters SSD. And then when you go to run that container that contains that I/O sensitive application, you specify a constraint, and you specify it simply by using the --env flag, the environment flag. You specify a constraint and say, I need to be on a node with the SSD label. And Swarm will worry about scheduling it out to one available node with that SSD label that it is associated with. So constraints kind of operate mostly on nodes, whereas filters operate mostly on other containers. So let's say you've got 2 containers that are very chatty. They've got 2 applications in them that are very chatty, and they need to do a lot of communication. So really, you want those 2 things to always be on the same node. So you schedule one container out, and it gets scheduled wherever Swarm decides in the cluster, depending on your strategy. Then when you run the second node, you can specify an affinity, again via that --n flag, the environment flag, and schedule it out to be beside that other container, so they land on the same node and can take advantage of that local network bridge, and the chattiness doesn't incur so much overhead. If a node goes down in your cluster, of course, that's bad news. That's not something you want to see happen. But if it does, when you're actually when you're running your containers in the first place, you can specify another end flag to say, oh, reschedule me if my node fails. That way, if Swarm detects a node that has gone down, it's going to go ahead and rerun those containers that were on that dead node on the rest of the cluster, somewhere on the rest of the cluster, depending on the strategy. There's also on-cluster DNS, which is a very valuable addition to not only the Docker engine, but Swarm itself. And we're kind of still talking about pets and cattle here a bit. Thinking back to that previous 2 diagrams, even when you're using Docker and you're out in the cloud and you've got individual nodes, you're still caring very much about where you place those containers on which node. That's like one of the definitions of cattle is caring where things go. As we move into Swarm and clustering technologies, we care even less and less about that sort of thing in our environments. So I think it's fair to say at this point, cluster is the new normal. If you're thinking about deploying containers and Docker today, you're probably looking at one of these container orchestration engines, including Swarm. If you're thinking about doing it in 6 months from now or a year from now, you're almost certainly going to be using one of these clustering technologies. So it behooves you to start being a little more cluster aware. Your operations teams need to be more cluster aware, and even your applications and your developers start to need to be more cluster aware. So now that I've talked about Swarm enough, where do you actually get one? Where can you get one? So Karina is a new containers as a service product by Rackspace. It will create Docker Swarm clusters for you, like that. It's basically push button, receive Swarm. Literally, when you go in through the GUI, it's push button, receive Swarm. You download some credentials, that configures your Docker client, and you can start Dockering right away. Some of the benefits of Karina itself, we're running Docker on bare metal. So you get a pretty good performance improvement. We've, with some of our benchmarking, discovered that it's up to 60% faster than VMs, running containers on VMs. We've found that it's very intuitive and easy to use, not only from the perspective I was talking about before, because you can take all of your Docker knowledge, skills, and experience and apply it to Swarm. But actually creating your clusters with Karina is, we've spent a lot of time on the developer experience around that as well. And we kind of, in some ways, mimic what Docker Machine does, because that's what people are used to doing for our command line client. So very easy to use and get up and running in literally just a few minutes. You can go from zero, like not even being signed up, to running your first containerized Docker applications within 5 minutes. It is in beta right now, and we're looking to get out of beta by late this year, early next year. It's totally free to use at this point. You don't even have to include your credit card when you sign up, just because we want people kicking the tires and we want feedback. And we've taken a lot of feedback already. We've incorporated it into the product. We've incorporated it into the documentation. Okay, so on the topic of getting up and running in minutes, these are links to a couple of tutorials on the site. You can either go in through the GUI if that's your thing, if you prefer that kind of initial experience to be graphical and you can click around and see everything that you're doing. Or you can get started with the CLI. So from the command line, you can create Docker Swarm clusters. And because I'm a developer, I much prefer the command line. The rest of this presentation is going to be very command line heavy between Karina and using the Docker client. So to create a Swarm cluster with the Karina command line client, you do a simple Karina create. And this particular flag, wait, will wait until that cluster is actually created before it returns. So we're creating a 3-node cluster. When this command returns, our Swarm is going to be ready to use. And here it is, up and running, status active. Karina End My Cluster tells you what you need to do to configure your terminal session to start working with Docker Swarm. Okay? And this might look familiar to you. It's Docker Machine has a similar command. And likewise, you can do the same eval trick that you do with Docker Machine, in that you can eval this thing, it'll source it for you, and your terminal session is now configured to work with that Swarm cluster. And to show you what we've actually done here, there's 4 environment variables being set. 4 are kind of the standard Docker environment variables. We have our endpoint. That's our single endpoint, because we're only talking to one endpoint right now in our cluster. We're not talking to a bunch of individual nodes. We're talking to one cluster. TLS, up and down the stack, of course. Everything's authenticated and encrypted. All of our communication with the cluster. There's where all of our certs reside locally on your laptop or whatever your context is, whatever your environment is. I'll be kind of referring to my laptop as the context from which all of these commands are being executed. And then finally, Docker version is something that we put in there ourselves. So that lets you know what version of Docker that your Swarm cluster is. And we've also created a tool called Docker Version Manager, DVM. Because you can have swarms with multiple different versions, you need something to manage all those client versions on your laptop or on your Jenkins server or wherever it is you need to manage Docker versions. So DVM can do that for you very easily, and it keys off of that Docker version environment variable. Karina Help, of course, gets you all of the rest of the information that you need to work with it. So a bit of an overview of Swarm within the Karina Cloud. So, in this particular diagram, I've just got a 2-node cluster, just basically because of screen space. And we see that we have the Docker engine running on our node, of course. That's really the thing that's powering this whole beast. We've got some Swarm management containers. And then, of course, your user containers, your applications, your services that you're running. So you use the Karina CLI, like we just did in the previous slide, to create this thing. Using the Karina CLI to create the cluster. Once you have the cluster, you start using the Docker CLI or other Docker ecosystem tooling to start working with your containers on the Swarm. There's a handful of constraints around using Swarm on Karina, and kind of the too long didn't read is that you don't have access to the underlying Docker node. It's a multi-tenant environment. We can't just have everybody accessing that underlying node. So what that means in practice is that you cannot use volume mounts. You can't mount into the Docker node with, so for exception here, for example here, you can use the, -- volume flag. This will fail because you can't mount into some path on the node. We do have the exception that you can mount the local Docker socket of that node, so you can communicate with the Docker engine directly on that node. And there's a lot of tooling out there that relies on having that Docker socket available to it so it can get access to Docker stats or the event stream from that particular Docker engine, and a handful of other things that you might want to do on a particular node. And there's more on this in the data section of this presentation. You can't use the privilege flag or capability add or drop because we can't have privileged commands being run on the node. That's just bad news for everyone involved. We also have AppArmor restrictions also enforcing greater security on the node. And because I mentioned we have some swarm management containers running on your cluster, like the Docker agent, the Docker master, all those things are running as containers on your cluster. This is just how Swarm works. Try not to remove them. You'll totally bork your cluster. But that's okay, because we've accounted for this situation, and you can do a Karina rebuild if that's the case. And we're actually working to improve that experience and set it such that you cannot delete those management containers using the Docker authorization plugin, which is kind of an under the hood thing that I'm not going to get into. So now that we've got our Swarm and we've got our Docker client configured to use it, we can start doing Docker commands. So we do Docker info, and this is just on a cluster with nothing that you've actually created yet. We've got already 13 containers running, and that's all the Swarm management stuff. And you can see we're using the spread strategy. We're just doing round robin spread of your containers across the Swarm, and we've got a 3-node cluster here. And this is just an example of those containers that you can see, and this is what you would see. There's actually this set of containers for all of the nodes on your cluster. Okay, so that's it for Karina. Now that we've got our Swarm, we're talking Docker from here on out. We're talking just like creating containers, running containers, everything about actually deploying your application on Swarm. So let's do something like the most basic thing you can, well, in my consideration, the most basic thing you can do to get started that's like not totally trivial, kind of beyond the hello world, and let's just create a little WordPress site. I always advise people starting by creating a network, and I'll get into why that's a good idea later. So we create a network called My Network, and we run a MySQL database. We configure it to connect to that network when it's running, and we pass in the root password for MySQL. It's just how the MySQL, the official MySQL image works. And we specify 5.6 for our image, because you always pin your versions, right? Even in Docker land. So we're up and running, we've got our ID. Now we go ahead and we run WordPress, connect it to My Network. This time we're publishing port 80 because we want to expose our blog to the world on a public IP address and let everyone know our amazing thoughts and illuminate them with all of our writing and content. We set the database host to MySQL. Notice here that that's just the name of the container. And I'll come back to that, the name of the MySQL container. I'll come back to that in a while. And then the password for MySQL, specifying the WordPress 4.4 image. We're up and running. So let's take a look at what we just did. And just looking at the last 2 containers we ran, everything's working, everything's happy. We go ahead and we do a Docker port WordPress 80. So that's saying, give me the IP address and port that's running on port 80, what was mapped. And we mapped 80 to 80. So we get back the public IP address and port 80. This is where our WordPress instance is running. And this is a Mac command doing the open here like this. Obviously, you get it on Windows or Linux or whatever. We're going to go ahead and we're going to open up that instance, and you can start blogging in Esperanto or whatever your native tongue may be, and let the world know what you're thinking. So that was pretty easy. A few commands, you can turn it into a script. You could use Docker Compose to knit all that stuff together and turn it into a single command to bring it all up with Compose. That works just fine too. When you start getting a little more involved with Swarm, deploying more applications, just working with it more and more, this is what I've been doing for the past 6 months, you hit a few bumps. I mean, this stuff is all a work in progress, like all software is. And what I'm trying to impart here is how to be a little more effective in getting over some of those bumps, and how you can actually work with Swarm a little more effectively. So it does take some experience there. You do get a few cuts and bruises, but that's okay. That's software. So let's start with something pretty basic here, the Docker image. Let's go ahead and pull an image and run a container. We're going to pull Nginx 1.9. It goes ahead and pulls to all the nodes on our cluster. We're going to run an instance of it and publish it to port 80. That's OK. So it's running on one node. Do it again, running on another node. Do it again, running on another node. So now we're running 3 instances of Nginx on all of our 3 nodes, each taking up port 80 on each node. What happens if I run it again? Anyone? It's actually going to tank. We're going to get an error because it can't find a node with port 80 available. I've taken up a limited resource, a limited public resource on my nodes. Each node comes with a public IP address. And I've taken up port 80 on the public IP address of each one of those nodes. So Swarm says, I give up. I can't find what you need. But that's to be expected because we've got a limited amount of port 80 on public IPs. It's to be expected, right? Now let's build a custom image. This is something very common that people do. Usually, it's your Python application or your Node application, whatever it is. Everyone who's working with Docker eventually is going to start building custom images. I'm going to use Nginx as an example here. And if you haven't kind of noticed, you can actually follow along with this stuff as you're working with it. If you visit that rack.to/swarm URL from before. Anywho. So let's go ahead, we'll download the Docker file for Nginx, and let's say we customize it somehow, we add something to it, we include some configuration or static files. We go ahead and we build it, and we tag it my Nginx. And this works just fine. We've sent the context out to a node, and now that custom image resides on one node in our cluster. So that's what we expected. We built our image, and that's just fine. So now let's run a container based on that custom image. And like before, we're going to take port 80. Let's say we've removed those other containers, and that's just fine. That works well. It's running, and it's happy. Now let's go ahead and try to do that again. What do we think is going to happen here? 3-node cluster. There's nothing else taking up port 80 on any of the other nodes. Say again? Right, yeah, you've got it. So the answer there was, did you upload into the other ones, or did you upload it once? I only built it out to one node in my cluster. So Swarm says, I can't find a node where that custom image resides. And it's not unreasonable thing for Swarm to default to this behavior. Because you could very well have hundreds of nodes or even 1,000 nodes in your cluster. You can't be building out to all of those nodes. That would take a ridiculously long amount of time and consume all sorts of bandwidth. And it probably wouldn't meet a lot of performance criteria that people really need in a production environment. So the solution here is to run a container using a custom image. This actually takes you to some documentation that we have on the Karina site. And there's a handful of ways that you can actually work with this. I'm not going to try to zoom it. I apologize if it's a bit small in the back. I don't want to mess up my resolution here. So you can use a constraint, and you could actually build it out to every single node in your cluster, and like literally in a for loop, do that thing that I already recommended not to do and build it out to every single node in your cluster. That is an option. It's a bad option. You can use an affinity. That's actually what's going on when it first runs on that one node that actually has the image. It's an implicit affinity because we didn't actually specify it. We didn't have to explicitly specify it in our run command. Use Docker Hub. You can go ahead and you can push your image out to Docker Hub and then go ahead and pull it back down to your cluster. Now, in that case, like we saw in that initial example, it gets pulled down to all the nodes at once. If you have a lot of nodes, it could be pulling to a lot of nodes, and that too can be a very time-consuming and processor-intensive process. Not so much processor-intensive process, but you're also going to take up a lot of disk space. You can use some other public Docker registry to push to, like Quay or what have you. Maybe the best solution, but also one of the more complex solutions, also probably ideal for a like production rollout on an actual Swarm cluster, is to use a private Docker registry. So you deploy Docker registry. You can do it either on your cluster. In Karina's case, you would do it on your cluster. If you're using Swarm somewhere else, you could also have it somewhere close to your cluster. As long as it's on the same network, that would probably be good enough. So you go ahead and you run a private registry on your cluster, back it with some object store, or you can use local disk as well, but it does consume a fair amount of disk space. And then you push your image to that private registry, and then when you go ahead and you pull to your nodes, they're all on the same network. It's all going to pull very, very quickly, and you get the additional benefit that things are a little more secure because all of your images are on your own private registry. Let's talk a bit about data and Docker Swarm. Let's go ahead and create a volume and write some data to it using the Docker volume command. This is something that's relatively new, came out around 1.7 or 1.8, and we're going to create a volume called my data. Okay, created. That's great. So what this did was, we're listing our volumes now. What this did was create a volume identically named across every single node in our cluster. So we have a volume with the same name on every single node in our cluster. Let's go ahead and write some data to that node. And notice how we say -- volume. We specify the name of the volume. And I'm mounting a /test in there just because why not. And writing a little bit of file data to that volume. So that worked exactly as we expected. We have a little bit of file data in one of our identically named volumes on the nodes in our cluster. So let's go ahead and try to read that back. So I'll go ahead and I'll run another container that reads from that volume name, my data. It worked. Great. It worked. Great. What do you think might happen next time? Anyone? So we hit an error here. No such file directory. And actually having those two run successfully at first was a bit of a red herring for you. It was really just by chance that that container that was reading that file data back landed on the container that happened to have the file data that I was interested in. We've got identically named volumes on all of the nodes in our cluster, but we have unique data on one of those volumes. We can't actually identify to Swarm which volume we want. So how do we get around that? So one possible solution, if you're up for it, is to use a distributed file system that works with your cluster. We don't have this on Karina, but if you're running Swarm on-prem, then if you're also willing to run Ceph or Gluster or NFS, if you've got the operational skills and capabilities to do that, then great. You know, using a distributed file system as the store for your file-like data works perfectly well, can work perfectly well. But really, for like ephemeral file-like data, data volume containers is another great solution. It's been around. It's a pattern that's been in the Docker ecosystem for ages, like since very early on. It still works very well with Swarm, and I use it literally all the time. A lot of our tutorials start by creating a Docker volume container. And sometimes really intended for kind of ephemeral file-like data, should be just kind of temporary data that's written to it. But sometimes we've found from our users that their temporary ephemeral data isn't quite so temporary or ephemeral. So we recommend very strongly that you always back up and restore and be able to restore your container data and even do it on a cron schedule, if you will. That works out very well. This last link here is an issue I opened with Swarm, or maybe it was with Docker Engine, saying, this scenario, this default behavior of creating an identically named volume across all these things maybe doesn't work so well in practice. And there's some agreement on that issue there. Some other solutions, if you're not necessarily storing file-like data, if you've got database data, production data that you really need to store and completely rely on and have it highly available and redundant and all the good things, you might want to store it somewhere off cluster. Like certainly you can use containers for this sort of thing if you're willing to accept the risk of accidentally blowing away your data. Again, back up your data and be able to restore it. I can't stress that enough. Or you can connect to a Rackspace MySQL DB, or if you're into Mongo, you can connect to Object Rocket, MongoDB, and just keep your data off cluster. It also makes upgrading your clusters, migrating to new clusters of newer versions much easier when you can just simply blow all your containers away, start them up in a new cluster, and keep going, because you're just reattaching to your data stores off cluster. Talking a bit about networks. So let's go ahead and run Redis, and we're going to write some data to it and read some data from it. So we go ahead and we run Redis, and we're publishing its standard port. That's fine. That's all well and good. I find out where it is. It's at this public IP address on this port. Sounds good. I'll use the Redis CLI from my laptop to talk to that IP address and write a little bit of data into that Redis database. That works just fine. I'm going to go ahead and I'm going to read it back. True, it worked. It's fine. It's great. Or is it? What really sucks about this? I've got a container publicly exposed on the internet, and I can connect to it totally unauthenticated and unencrypted. This is bad news. The internet's an ugly place. Someone is going to take this and do horrible things with it. Who knows? So we've got this thing that's exposed and shouldn't be. Let's go back to our another kind of networking scenario. Let's go back to our WordPress example. This time I'm not going to create a network, and I'm just going to start running my MySQL and WordPress containers. So sure, they come up just fine, and I go ahead and I refer to my MySQL container again by its container name. This time though, I check out the logs, and I find that WordPress can't find MySQL. Can't find something named MySQL. It's kind of a drag. Makes things a lot more difficult, because now I got to go out and find something named MySQL or what its IP address is. So what can we do here? The solution is to just start using an overlay network. This is a very handy construct in Docker Swarm. We've got it on Karina. We added it several months ago. As soon as we did, our whole team went through all our tutorials and just started adding overlay networks everywhere. Because it provides you, it minimizes your exposure. If I put that Redis container on an overlay network, it gets a private IP address. Its port is only, and you don't publish the port, you expose the port. You just use --expose. It's only exposed on that private IP address of that overlay network. So you're limiting the attack surface, you're limiting the exposure of that container to exactly what you want it to be. And you also get that nice DNS resolution of your container names. You've got, on every single Docker engine, there's a DNS server running, and you can ask any of them for any container name. And so if I ask it for the MySQL container name, that's going to resolve to the private IP address on that overlay network. Okay, so prefixing the bit on security with I am not a security expert, but I'd at least like to share a handful of things I've learned. Of course, the clusters we create for you have TLS up and down the stack. You've got all your certs, all your authorities, all your keys, all ready for you. That's kind of one of the things that makes it so easy to use, is that Karina takes the headache of creating this stuff and managing it out for you. So, we've got our TLS verify 1 and the path to our certs. And if you look in that cert path, there's also a README that describes all of the things that these certs and keys and authorities do for you. And this is something you either download from the GUI or you get with the command line interface. So that's good. We want TLS. Some other solutions that we've worked out as we're working with Swarm. Again, use overlay networks. You can really limit your attack surface for your application containers. There's also utilities like Watchtower that will watch your running containers. And if the base image gets an update, probably because security patches, Watchtower will notice that, restart your container, and then that will take the new patches from that base image. So you're always getting your patched container. Your container is always being patched. Now your application has to be willing to be restarted whenever, but that's probably a property your applications should have anyway, ideally. We have a great tutorial on Nginx with Let's Encrypt. It'll get you an A+ rating with SSL Labs for deploying Let's Encrypt in a Nginx container. And honestly, that'll work wherever you are. Just a really, really well done tutorial. We've got a work in progress tutorial on public key infrastructure, managing that within a cluster if you want to put like a good solid tinfoil hat on and make sure everything is encrypted between every single hop, which really isn't a bad idea. This last one is an issue where we're kind of putting it out there to people. Is something that you value would be creating like a security sidecar on every node in your cluster, something that's watching your containers to see if they have any vulnerabilities. And there's a handful of things out there that do this sort of thing, from CoreOS, from Docker, all offer these kinds of utilities that monitor your containers for security vulnerabilities, mostly using the CVE database. Moving on to service discovery. So kind of a typical scenario here is that you've got some container that comes up and it offers some service and needs to be, let's say it's your Python web application, and it needs to be registered in a service registry, some key value store, some highly available, consistent key value store. So container comes up, gets registered. Now you've got another container over here that's like interested in that service. I have some relation to that service, and typically what that is a load balancing scenario. That's a very common use case. This service here is actually a load balancer, and it says, I want to add that service to my pool of load balance servers. One solution here, kind of a great out-of-the-box solution with Swarm, is to use DNS round robin. So another aspect of that on-cluster DNS with Swarm is you can create network aliases. So these network aliases, containers can participate in. You've got all these containers declaring, oh, make me part of this network alias when you run them. Then, if you refer to that network alias from somewhere else on your Swarm, from a load balancer, let's say Nginx, when you refer to that alias, you're actually going to get an IP address back of each container in a round-robin fashion. So you're referring to one alias, and it's round-robining the IP addresses that you get back. So you've got pretty simple, reasonably effective service discovery and load balancing just out of the box. It's good stuff. Another step higher in the service discovery game is using a tool called Interlock. This is something it's not an official Docker project, but it's written by a fellow who works for Docker Inc. You can go to it and check it out on GitHub. I'll explain kind of the architecture of it in the next slide. I've contributed to this project with a couple of pull requests. When I came to it, I was like, oh, it could really use these features. And so I'm like, I guess I'll do it myself. Why not? So you can now externalize templates is in the 1.1.1 version. And being able to work with multiple different services in Interlock is still in a pull request right now that I haven't been able to finish because I'm standing on the stage in front of you talking about it instead of actually working on the pull request. I apologize. So here's how Interlock works. Essentially, you've got an Interlock container, or Interlock running in a container on your swarm, and it's managing a load balancer config. Let's use Nginx as an example. So it's managing the Nginx conf of a running Nginx load balancer. Interlock is watching the Docker Swarm event stream. When a container comes up that Interlock is interested in, that it wants to load balance, it'll see that container come up, inspect it for its IP address and port, and write that out to the nginx.conf of its associated Nginx container. So it's pretty basic, and there's not so many moving parts. There's really kind of only one extra container in this scenario, and that's Interlock itself. You're always going to need your load balancer. You're always going to need your service containers. In this case, you've got just the one extra container managing your load balancer. So in the DNS solution, no extra containers. Interlock, one extra container. And then if you need like the full service discovery smorgasbord with all of its associated power and features and complexity and additional containers and moving parts, you can adopt a stack like the etcd stack and use that for service discovery. And like this stuff is a talk on its own. Likewise with the console stack, there's just a ton of things you can do with this stuff and use it in a dozen different ways, and there's lots of good resources out there on the web for learning how to do that. So we're kind of wrapping things up here. I wanted to talk about some of the use cases that we've discovered and that we've done ourselves, that our users have done, some of the great stuff that people have come up with. It's really very cool. I do want to say that there's this develop a Python web application tutorial on our site. And this this is one written by me. It basically incorporates pretty much all of the effective ways of using Swarm that I've talked about here today. And it does so with Compose. And weaves in all of these different ways and starts with developing with Docker Toolbox on your laptop and then moves out into Karina. This other stuff is going to be much better explained by the people who actually wrote it. And that's going to happen in this room at 2:40 p.m. With Think Outside the Container, led by Carolyn Van Slick on our developer experience team, and a couple other folks, a couple other Karina users who have deployed stuff on Karina on Swarm. And this one is particularly cool. This is the one from Carolyn, teaching you how to whale. You're able to use Docker to run Docker to learn Docker, all using Jupyter notebooks. I don't know if you're familiar with that, but that's like that's like a whole ecosystem of stuff. Jupyter and Jupyter Hub, interactive web pages is essentially what it is, where you're able to run code and commands. Very cool stuff. And again, these are all links on the bottom. Of course, websites you can run. This is a site powered by Karina, Scout-A-Park, built by some great people here in Austin who've deployed it on Karina. And finally, just quickly wrapping up, thank you so much for your time and attention here. You can check out the presentation at rack.to/swarm. I encourage you to check out getkarina.com. Thanks so much.